All right. Good afternoon, everyone. We are so excited. Happy Mars Day, everyone. Good afternoon. We are here at the Science Center. My name is Carissa Cedor, and I am here with Kayla Wogman. Kayla, say hi.
Hello, everyone.
And we are so excited. We are watching NASA TV right now as the Perseverance Rover makes its way to the planet Mars. It is on its way right now, and it's going to be touching down in just about 20 minutes from now. So we are watching this whole thing happen in real time. We're very excited for this rover to make its way down to the surface today. This is a really exciting process because it's been traveling to Mars for about 7 months now. It launched last July, and it has been flying to the red planet this whole time. And today it's going to be making its entry, descent, and crossing our fingers for a successful landing. So we are taking a look at this awesome mission. It's been many years in the works. It looks a lot like the Curiosity rover that landed on Mars in 2012, but this mission is really different, and a lot of new features have been added to this rover for this process. Now, just under 4 minutes, we can see on NASA TV right now, this rover is in what it's called its cruise stage. So it has a little protective shell around it, as well as the solar panels on the back that have helped power all of its systems on its long journey to Mars. But the first step that we're going to see in just under 4 minutes from now is that cruise stage separation. So what's going to happen is those solar panels are going to leave, they're going to detach, and we're going to be just left with the capsule that's going to be making its way down to the surface. Now, before we do that, all right, so we're getting ready for that first event to happen. Megan, do we have audio coming from NASA TV? Great. Ooh, I'm not sure if I'm able to hear it. Can we? Kayla, are you able to hear that audio there?
Able to hear that.
All right, so we're going to keep checking on the cruise stage. Right now, we're getting ready. Here we can I'll give you guys a close-up view. We can actually see kind of the view that Perseverance is seeing right now. I have it up on the planetarium dome. And we are able to see that back shell that's going to be separating soon, the solar panels off of that back shell, rather, as it gets closer and closer to the red planet. So getting ready for that stage. Now, Perseverance is not going to be by itself on this mission. The rover is going to be landing, but there's also something new going down with this one. Kayla, can you tell us a little bit about Ingenuity?
Oh, I most certainly can. Ingenuity is the first helicopter we're going to be flying on Mars, which is so incredible. It's about the size of a softball. It only weighs about 4 pounds. And we've got a little video that we can kick over to see a little bit more of what Ingenuity actually looks like. Let's see if I can do a quick screen share here. There we go. There we go. And there we can see Perseverance. Now those blades that we see spin at 2,400 RPMs. The atmosphere of Mars is only about 1% that of it is here on Earth. So we need to spin very, very quickly to be able to lift off. Hopefully this is the view we will have in about a month after Perseverance lands. We're going to try this lift off. We've got all types of cameras. There's 2 cameras on Ingenuity, one that shoots in black and white and one that shoots in color. And this is really amazing because if we can lift off on Mars, think of the potential that we have in the future. If we can get this little drone to fly, maybe we can fly a helicopter on Mars. There's already talks about potentially using a helicopter to right rovers that have tipped over or transport loads to different areas on Mars. And if we can do it on Mars, maybe we can do it on the moon as well.
All right, so we're going to see here on NASA TV very shortly that crew stage separation did occur. So those solar panels come off the back, and now that capsule is going to get ready to orient itself in the right position to head down into the Martian atmosphere.
I think it's important for everyone to remember there is a delay in our radio communication
toward Mars,
our rover.
And we'll eventually hitting the top of the atmosphere. We're not far away. This is going to go very quickly from here on out.
All right, so we're seeing the team in real time, kind of tracking this data as it comes in.
Pass through our beam to the Earth.
Telecom indicated actually that we could see a signal that the crew stage went between the Perseverance entry capsule and Earth. So we saw a little blip, the data stream indicating crew stage separation. We have confirmation that the vehicle has started warming up those entry thrusters. Warm pulses have begun.
All right, so now Perseverance is going to go through kind of a series of actions that is going to orient it in the correct position to hit that atmosphere. And so that's going to happen in about 8 minutes is when it's actually going to make contact with the Martian atmosphere. So the Martian atmosphere is a lot thinner than our atmosphere here on Earth. Here on Earth, our atmosphere is a nice thick blanket that covers our planet, and our air that surrounds us is nice and thick, which works out well for us Earthlings, right? It helps keep us alive down here. It helps keep us breathing, but it also helps protect us from things in space. If you've ever seen a shooting star at night, that's a meteor. That's a small rock or pebble that's actually burning up in our atmosphere. When things hit an atmosphere, they're going really fast from outer space. And what happens is they're moving so fast, they start to hit our air molecules, and friction starts to heat everything up. And it heats it up so much that it actually starts to vaporize, it starts to burn, which causes those big streaks of light that we're used to seeing. So that is essentially what's happening here on a much larger scale, right? If we have a spacecraft entering an atmosphere, it's going really fast and it's going to start to burn up essentially. Now, fortunately, scientists put these heat shields on spacecraft. So if you've ever seen the space shuttle re-enter, it has a special heat shield to protect it from all of that heat, as well as the spacecraft that we send to other planets. So that bottom shell is going to serve as a thermal layer, kind of a protective blanket, as Perseverance starts pushing through the Martian atmosphere. Now, here on Earth, our atmosphere is really thick, right? And we can count on our thick atmosphere to that friction really slows things down. The Martian atmosphere is about 100 times thinner than our atmosphere here on Earth. So it does not slow things down quite as much as we would like, right? So it needs extra help in order for it to slow down a lot more. So we're going to see that kind of series of events unfold over the next few minutes here, over the next 10 or 12 minutes. As it starts to go through the Martian atmosphere, we're going to see its parachute deploy.
Really steep angle of 15 degrees.
And that parachute has to be strong enough to slow it down. It's actually going faster than the speed of sound right now. So it's a supersonic parachute, not like parachutes that we're used to working with really here on Earth. It has to be really strong, really big. So we'll see that parachute come out in just a few minutes here.
Prior to entry, the Mars Reconnaissance Orbiter should begin receiving telemetry from Perseverance and streaming to Earth in near real time. There are a few expected short outages, such as when we have a plasma blackout or when we enter the peak heating phase. Aside from these outages caused by the plasma blackout, antenna switching, or high dynamic events, spacecraft events, We should have telemetry until about 90 seconds after landing. A part of a blackout is when the signal from Perseverance isn't strong enough to make it through the superheated, super fast air blowing around the spacecraft all the way down to Earth. Once the temperature drops below that peak heating, we do reacquire the signal from Perseverance. We are currently about 4.5 minutes from the entry interface. Perseverance continues to report heartbeat tones, indicating everything is nominal.
Okay.
All right, so that is a great sign. So essentially what they're talking about here is the various orbiters that are currently around Mars. So there are spacecraft orbiting Mars, and they have been there for a while, taking pictures of the surface, taking and analyzing the surface of Mars. But today they've all been assigned to actually watch this process happen. They're going to watch the rover go to land. So we've got a couple, we've got the Mars Reconnaissance Orbiter and MAVEN. Those are two different spacecraft that are following from the skies. So even though we can't be there to watch, Perseverance is going to have a robotic audience today, and they're going to be watching this whole thing, taking lots of pictures, and actually sending data back to Earth. Because as she mentioned, when Perseverance is going through the atmosphere, all of that heat, the signal can't really make it through that whole process as it's kind of making its atmospheric entry. So we're going to be relying on these orbiting spacecraft to tell us whether or not Perseverance is doing good. But right now, she said everything sounds nominal, so that is good. As long as we keep hearing that word, that's our favorite word to hear, nominal.
What's really cool about Perseverance is they've added on an extra microphone for this trip. So at some point, they're going to kick on a microphone so that we can hear what it sounds like to actually be landing on Mars, which I think is incredible. We're also going to hear for the first time what it sounds like on Mars.
So right now, Perseverance is at an altitude of about 200 miles. That's roughly the altitude that the International Space Station orbits the Earth here at home. And it's going to be making its approach getting even closer. Now it's at about 180. So it's moving pretty quickly, making its close approach. But yeah, I'm excited to hear some of the sounds. That's not something we've gotten to hear before.
And if after this stream you want to hop onto NASA's website, they were predicting what it would sound like in a Martian atmosphere, because the atmosphere is very different to what it is here on Earth. They're predicting that sounds will be a lot more muffled when you're on Mars. So it'll be interesting to see how accurate were our predictions on what it would sound like to be on Mars.
So I'm going to give you guys a view of what I'm looking at. There is a simulation that you can look for. It's run by NASA Eyes. And if you just search for NASA Eyes Mars 2020 simulation, you will be able to find this as well. So I'm actually kind of watching in real time what is happening with Perseverance. And right now it's getting pretty close to the surface of Mars. There we can just barely see the curvature.
Now we are heading towards a very special landing site. We're heading towards Jezero Crater. We believe that this was a delta. So we believe there was water here, and we're hoping that we will find signs of microbial life listed on Mars.
Yeah, that's one of the really cool things about this mission is it is taking a look and landing a rover in a area where they've never really attempted to land before. It's going to be a very tricky entry. The surfaces in this area is going to be really rocky. It's full of cliffs and rocks and things that are normally pretty dangerous for a rover. But fortunately, this rover is going to be really smart. It's going to be looking very soon to figure out exactly where it's going to land. And again, because the signal takes so long to reach from Earth to Mars, it's doing all of this autonomously. So these engineers are not actually controlling the rover right now. It has to be able to take in this data, figure it out on the spot, in real time to figure out where it's going to land. And we can see right now it has officially entered the Martian atmosphere. So it is on its way. That heat shield is going to start heating up, getting a lot warmer.
Currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars.
So our 7 minutes of terror is we do not have communication, as Carissa mentioned a couple times with our rover. It does take time for those communications to reach us or the rover themselves. So it's hitting the ground in 7 minutes, whether we're ready or not.
But I think right now we're going to turn it back over to NASA TV. So Megan, go ahead and crank that volume on NASA TV. We're going to watch, because the 7 minutes of terror have officially begun. It is on its own. It is on its way. Let's hope, everyone cross our fingers. Let's watch this rover land on Mars.
Velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO plasma blackout at this point.
It should be doing its turns right now.
MRO has lost log.
Perseverance. We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
We saw a small outage of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target. Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, but to the target on Mars, but instead is flying straight to the target. Our current velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
MRO is reporting good telemetry log.
We are coming upon the straighten up. We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground. The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration in the velocity. Our current velocity is 430 meters per second at an altitude of about 12 kilometers from the surface of Mars. Perseverance is now slowed to subsonic speeds and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Yes.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers of the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers. We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation. We have timing of the landing engines. Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about 1 kilometer off the surface of Mars.
Here in safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the flight crane maneuver.
We've lost direct to Earth tones.
As expected.
Sky crane maneuver has started. About 20 meters off the surface.
We're getting signals from MRO.
UHF is good. Touchdown confirmed. Perseverance safely. A pass flight. The descent stage has flown away to a safe distance. Perseverance is continuing to transmit direct through Mars orbiter to Earth.
That is a successful touchdown.
This is so exciting. And the team is.
Oh, that was amazing.
It's so.
Of course, they're still getting telemetry from the lander.
All right, all stations.
We got it.
Touchdown
We're there.
confirmed. We're gonna wait for the images.
Wow. This is so exciting. The team is beside themselves. It's so surreal. Stay tuned. We might get some pictures.
So that is official, everyone. Thank you for joining us. That was awesome. They have successfully landed this rover on Mars. They've done it again. That was amazing. We highly encourage you guys to keep watching the NASA TV stream today because they're going to keep their eyes on this rover. This is all happening in real time. Hopefully very soon we'll be getting some pictures from Perseverance as it will eventually raise its camera up and start taking pictures of its landing site. We might even get to see some pictures from those orbiting spacecraft from the Mars Reconnaissance Orbiter, but also Maven, who were watching that whole thing from above. So we're definitely going to be looking for those as well. But that was very fun. Hopefully you all had as much fun as we did taking a look at this amazing spacecraft that's going to be making its way across the Martian surface, taking a look at some pretty amazing things, going to be doing some amazing science, drilling down into the surface, deploying that drone helicopter, and sending back lots of information and insights into the Martian past. Kayla, do you have anything else you want to add? I'm all jazzed up over here.
I'm I am just incredibly excited. The opportunities that we're going to have from this rover are insane. Like we said, it is looking for microbial life, which is huge. Life on another planet could have existed, and we're going to know soon thanks to this little rover, which is just, it's insane to even think about. And the possibility of potentially being able to fly on another planet. Ugh. I'm overjoyed. I can't believe it actually landed, and I can't wait to hear what it sounded like.
Yeah, I'm not sure if we mentioned it, but it is very difficult to do what was just done. I know NASA and JPL, their teams make it look very easy, but really only about 40% of these missions end up being successful. It's very hard to land a spacecraft on another planet. A lot of it due to that latency and signal. We can't communicate. It has to be able to do it itself. From now on, Earth will be sending it some instructions, and there are Mars rover drivers here on Earth that are going to be doing their jobs as soon as Perseverance kind of powers up, starts to do its thing. But it really has to be able to carry itself. So it's an amazing feat, amazing accomplishment. Those teams at JPL have all the reason to be celebrating today, and I'm glad that we can all be here celebrating with them. But I think for now, we're going to sign off. Thank you all so much for joining us today. Definitely keep watching that Mars feed. They're going to be going for quite a while, I'm sure, that NASA TV feed, rather, from Mars. And hopefully we start getting images very soon from Perseverance. And keep an eye on this mission because it's going to be doing some amazing science. We'll be talking about it for sure here at the Buhl Planetarium as their information comes in. Here at the Science Center, we'll be talking about it quite a lot. So come visit us and see what else is new. But for now, I think we're going to sign off.
Yeah, I think we have some visitors out there that have some excellent questions that we should go address.
I'm ready to go party.
All
Happy
right.
Mars Day, everyone.